Welcome to Anand Sir YouTube channel. Today we are going to start a very new course which we have announced earlier, that we will be uploading some lecture related to UPSC ESC, that is Union Public Service Commission Engineering Services Examination, and the branch that we are going to consider here for this exam is civil engineering. So first we will upload some lectures in civil engineering series, then we will move to some other branches. So this video will be very useful for those students who are preparing for civil engineering related engineering services examination. Now there is one more important topic, or I can say a subject, which is known as fluid mechanics. So in fluid mechanics we have to study one chapter known as open channel flow. So this chapter has to be studied in very detail for engineering services examination. So from this chapter today we are going to take one topic which is very common, that is economical channel section. So first of all we should learn what is economical channel section. So a channel is said to be economical if its cost of construction is minimum for a given discharge. Okay, so channel is said to be economical if its cost of construction is minimum for a given discharge. Q here represents discharge. Okay, and when we will say a channel is most efficient, when its cross-sectional area is given. Then that means if its cross-sectional area is constant and we are trying to get maximum discharge out of this given cross-sectional area, then that channel will be said as efficient. Okay, so in economical we are keeping the discharge fixed and we are making the cost of construction minimum, but in the case of efficient we are keeping the cross-sectional area constant and making the discharge maximum. Okay, so how can we find this economical or efficient section for a given shape? Okay, let's try to find it one by one. Okay, so if we are considering for a maximum discharge for a given area, then we have to make its perimeter minimum. Okay, we have to make its perimeter minimum, and we know that from the previous equations that Q is inversely proportional to 2/3 the power raised to perimeter. Okay, and we have Manning's equations. What are Manning's equation? Manning's equation is Q is equal to 1 by n a r to the power 2 by 3 s to the power half. Okay, and here r is equal to a by p. So if we put r is equal to a by p, then what we will get? 1 by n a by p power 2 by 3 s to the power half, and if we combine a to the power 1 plus 2 by 3, we will get a to the power as 5 by 3. So from here we are getting 1 by n a to the power 5 by 3 p to the power 2 by 3 s to the power half. So from here we can simply say q is inversely proportional to p to the power 2 by 3 if its area is given, because s and n in the above equation is already constant. Okay, so what is the conclusion we are getting from here? Conclusion is that in the case of both most economical and most efficient, okay, in both the channel section, we are going to make perimeter minimum. Okay, so in the case of most economical and most efficient channel section, we are going to make perimeter minimum. So let us take the first case, where we will derive some formula for most efficient rectangular channel. Most efficient rectangular channel. So if you are taking a rectangular channel, let us draw its shape first. So after drawing, let us mention some point here. This is the water top surface, this is the width b, this is the depth y. Okay, now if you calculate the cross-sectional area of this section, what we will get? A is equal to b multiplied by y, and if we have to calculate the wetted perimeter, we keep in mind the p here, it is wetted, so wetted here is b plus y, that is b plus 2y. So from here we can get b is equal to a upon y. So let us put this value of b here, then p becomes a by y plus 2y. Here you have to keep in mind that area is constant. Okay, now what we are going to do next, since we are calculating for most efficient rectangular channel section, we have to keep the perimeter minimum. So mathematically that means its derivative should be 0. dp by dy we have to make 0 to find the value of p, where find the value of y where perimeter will be minimum. So let us calculate dp by dy. So dp by dy will become minus a by y square plus 2. Okay, Now make it 0. Minus a by y square is equal to minus 2. This gives us a is equal to 2y square. And since a is equal to b into y, here we can write by is equal to 2y square, or we can write b is equal to 2y, or we can write y is equal to b by 2. That means perimeter is minimum when the depth of the channel section is half the width of the channel section. Okay. From here we can calculate hydraulic radius also for this channel section. Hydraulic radius will be equal to r is equal to a by p. That means r is equal to a, already we have calculated, that is b into y. Perimeter is b plus 2y. So we have already seen that b is equal to 2y. So let us put 2y into y, 2y plus 2y, this will be equal to 2y square divided by 4y. Now this simply becomes r is equal to y by 2. Okay. So what we can say here, that for most efficient rectangular channel section, depth of flow y should be equal to b by 2, and hydraulic radius r should be equal to y by 2. Okay. So this is the formula we have calculated for most efficient and economical channel section for rectangular cross section. Okay. In the next video lecture we are going to calculate the most efficient and most economical channel section formula for trapezoidal section. Okay. So if you have liked this video, please subscribe to my channel and get updated for the next video lecture. Thank you for watching. Have a nice day.